In this session, we'll be talking about binomial expansions, as a lot of people are requesting for a video on binomial expansions. Let's quickly get into it. We know binomials, right? Two terms in an expression that are separated or connected by addition or subtraction. For example, if you have a plus b, right? A plus b, this is a binomial. Right, the first term, second term separated by addition. Then you can also talk about 2x minus 3y. That is a binomial, two terms separated by subtraction. We can give a lot of examples. You can have p minus, let's say, 7q. That is also a binomial. All right, when the powers of these binomials begins to increase, expansion becomes a bit difficult. For example, if you are having a plus b to the power 2, this is very easy to do. If you're having a plus b to the power 3, we can do this easily. But if the power begins to increase to, let's say, 5, and then let's say a plus b to the power 7, like that, using the normal expansion approach becomes a bit difficult. But the Pascal triangle makes it a bit easier. So we'll be looking at the Pascal triangle in this video, and then in the other videos we'll look at how to use the combinatorics or the combination method, the method that involves combination, and then the binomial theorem. But in this video we're looking at how the Pascal triangle came about. So let's quickly look at that. If you are given this binomial a plus b to the power 0, this function is going to be 1. Or if you want to expand this, you're going to get 1, all right, because every quantity to the power 0 is 1. All right, and let's look at this one, a plus b to the power 1. All right, we all know that if you have a quantity and it's raised to the power 1, it's the same quantity. So if you have an a plus b to the power 1, the expansion is a plus what? B. Let me leave the coefficient for now. I'll come to that. If you are having a plus b to the power 2 and you have to expand that, let me do that here. What it means is that the a plus b to the power 2, it means the quantity a plus b would multiply itself. So we have a plus b times a plus b, right? A plus b times a plus b, and we know how to do that. You just FOIL and then you get the answer. So a multiplies a, the a multiplies the a over here, then this multiplies the b, then b multiplies a, then the b multiplies what? The b over there. So we have a times a giving us a square, then a times b giving us ab, then b times a giving us ab, and then b times b giving us what? B squared. So this is going to be, it's going to give us a squared plus, ab plus ab will give us 2ab plus what? B squared. So a plus b squared, the expansion is a squared plus 2ab plus b squared. All right, good. These are very easy to do when the power is smaller like this. It's very easy, a bit simple to do. All right, from here let me begin to write the coefficient. So the coefficient over here is 1, right? It's 1. And then when you come to the second line over here, the coefficient of a over here is 1, and then the coefficient of b is also what? 1. So we are having over here 1 and what? 1. Okay, all right. Then when you come here to the power 2, the coefficient of the first term is 1, as we know. The coefficient of the second term is what? 2, and then the coefficient of the third term is what? 1. Okay, so we are going to have 1, 2, and what? 1 as the coefficients of the binomial to the power 2. Now let's expand a plus b to the power 3. Let's do that expansion over here. A plus b to the power 3. What it means is that the quantity a plus b is multiplying itself 3 times, like that. And you can imagine, if it's to the power 4, it means it's going to multiply itself 4 times. If to the power 5, it means it's going to multiply itself 5 times, if you want to go by the normal expansion approach. But sometimes this becomes very difficult, or it involves a bit of a work to do. That is why the Pascal triangle comes in. So let's see how we do this. Over here we said a plus b times a plus b, right, is given as this. Okay, so a plus b times a plus b is equal to a squared plus 2ab plus b squared. Okay, so that has been done already. It's given as this times the third bracket. So we have a squared times a will give us a cube, and then a squared times b plus a squared b. Then you're having 2ab times a, so we have 2a squared b, then 2ab times b, so we have plus 2ab squared. Then we have b squared times a, which is giving us ab squared. Then we have b squared times b, giving us b to the power 3, or b cubed. Right. You can simplify this, and then you'll be having a to the power 3 plus, we have a squared b plus 2a squared b. That is 1a squared b plus 2a squared b, which is giving us what? 3a squared b, right? Plus 2ab squared plus 1ab squared. So you're going to get 3ab squared plus what? B cubed. Okay, and so that is the expansion for the binomial to the power 3. Let's quickly put it over there and then make some analysis. So we have a to the power 3. So to the power 3 plus 3a squared b plus 3a b squared plus b to the power 3. Okay, that is the expansion for the binomial to the third power. And you can see the coefficients. The coefficient of the first term is 1. So let me put 1 here. Have 1. The coefficient of the second term is 3. So let me put 3 here. That is 3. And then the coefficient of the last term is what? 1. So we have 1 over here. And then you can see that the coefficients, as it comes to the base, or as it looks like a triangle, right? Having a look like a triangle, all right? So we can continue and then get the expansion for the binomial a plus b to the power 4. But I don't want myself to do that expansion. But then we can look at the coefficients we are getting over here, and then we can develop some pattern, okay? But I must say that this is what we call the Pascal triangle. The coefficient of the expansion we have over here is what creates or what forms the Pascal triangle, right? Because it looks like a triangle, or the base gets broader as the power increases. All right, you can develop some pattern, so there's no need to even expand this before you get the coefficients over here. So let's see how you do that. See, when you look at the top over here, we have only 1. When you look at the left over here, there's nothing over here. So it's assumed that it's 0. Okay, so 0 plus 1 will give us what? 1. All right. When you look at the right over here, there's nothing. So we assume it's 0. So 1 plus that 0 gives us what? 1. Is that right? Good. So when you come down here to the second power, when you look at the left over here, there's nothing. So 0 plus 1 gives us 1. All right. Then when you come here, 1 plus 1. Okay, 1 plus 1 gives us what? 2. When you look at the right over here, there's nothing over here. So you see 1 plus 0 gives us what? 1. Okay, it continues like that. The left here, nothing. So 0 plus 1 gives us 1. 1 plus 2 gives us what? 3. 2 plus 1 gives us 3. 1 plus nothing, 0 gives us what? 1. You see that? So it continues like that. So we can use that same idea and say that if we have to the fourth power, we can look at the left over here and see that there's nothing over here. So 0 plus 1 will give us what? 1. Right? And then 1 plus 3 will give us what? 4. Then 3 plus 3 will give us what? 6. 3 plus 1 will give us what? 4. And then 1 plus nothing over here, okay, will give us what? 1. Okay, so those are the coefficients for the fourth power. And that is how the Pascal triangle looks like. You can continue and generate the next coefficients. If you're having to the power 5 like this, a plus b to the power 5, there wouldn't be much time to waste. So the first one is going to be 1. 1 plus 4, 5. 4 plus 6, 10. 6 plus 4, 10. 4 plus 1, 5. And then 1 plus 0 is what? 1. And so that is the Pascal triangle. Okay, that's how it looks like. And we're making use of the Pascal triangle in the next video to do some basic expansions of binomials, or to do some basic binomial expansions. Let's look at something interesting. Someone can look at the Pascal triangle in this way. Alright. If you are having one over here, now you want to come to the base over here, or you want to come to this point on this base over here. Alright, there's only one way to come here. Okay, hence the one over here. Then also, if you want to come to this point on this base, there's only one way. Alright. Now, if you want to come to this point on this baseline over here, how many possible ways? So you have, someone can pass here, and pass here. So to the left, that's the first way, and then another way. So there are two ways to move from the top to this point on this baseline. If you want to move from the top to this point on the baseline, there's only one way. Well, that's a nice way to look at the Pascal triangle. Likewise, if you want to come to this point on the base, there's only one way, to the left. If you want to come to this point, this is one possible way, to the left like that. This is another possible way. And then that is another possible way. So there are three ways, of course. Okay, from here to the left, 1, then 2, then 3. So there are 3 possible ways to move from the top to this point on the baseline. Another one can also say that if you want to get to this point on this baseline, there are 3 possible ways. So one can pass here like this. 1, pass here, then come here. 2, then through this, and then come here. 3. Alright, good. So you can think about the Pascal triangle in that way too. Alright. So in the next video, we're using the Pascal triangle to do some basic binomial expansions. So watch out for the next video. If you've not subscribed to my channel, please subscribe and then hit the notification bell so that anytime videos are posted, you get them. Now let me leave you with this. To the power 6, a binomial a plus b to the power 6. Try and write out the coefficients in the Pascal triangle. Alright, so that is very simple. The first one is going to be 1, and as we know, 1 plus 5 will be 6, 5 plus 10, 15, 10 plus 10, 20, 10 plus 5, 15, 5 plus 1, 6, and then 1 plus nothing, 0 is 1. Thanks for watching.